SOC is over here and AppSec is over here, and they just never, ever talk to each other. And so communication is just not there. We end up with a system that's just fractured. You don't then throw those resources at trying to fix those vulnerabilities and start penalizing and punishing people because they're not doing it. That's not the way forward. The way forward is how do you change the system to prevent those vulnerabilities from being written in the first place? From my experience working with clients that I've worked with, when you drill into it, the different security teams are all over the place and they're just not talking to each other. That's not recursive. That's just random chaos. I think you've got to show them that actually what you're doing right now doesn't work. Do they understand that? Do they understand that they might not be viable? Is that a risk that they're willing to take at the moment? John Boyd, it was never about speed. It was always about doing the right thing at the right time and making the right decisions at the right time. It was never about making a decision faster. It was making a decision more effective and more efficiently.
Never get into A versus B situation. There's always a creative C, or there's infinite ways of looking at the problem space. Yes, there can be millions of vulnerabilities, but do they seriously challenge your viability? As in some cases, your attackers may actually want your site to be up and running and for you to be profitable and operational so that they can take that 1% or 2% fraud losses to their pockets. In a way, there's a symbiotic relationship going on there. Like if they wipe you out, they've killed their, golden, goose or whatever. And so, how and again, compliance is one lens that forces certain things. So it becomes a checkbox exercise, but then the real viability is determined by your level of, your ability to take damage, like financial damage, and yet continue to service the remainder of the customers.
Yeah.
Curious for your thoughts.
Yeah, that's a very interesting area. That's what automatically triggers the word resilience in my mind. A viable system is resilient to the environment it exists in. So we take an organism, and an organism an organism that's where the environment is changing. If it changes within the parameters it can handle, will be viable. If obviously the parameters outside in the environment change too much, then the organism will struggle. So imagine like if an organism needs water to survive, for example, and suddenly the environment dries out, then that organism is no longer viable. I think what we're seeing really with cybersecurity is the environment. We're seeing all these attacks happening. We're seeing different people doing different things in different ways. We've got different mental models of who that attacker is and what they're actually doing. And this is where System 4 is important, because we need to have that understanding of the environment that we're in and actually trying to, I wouldn't want to say predict, but certainly have this ability to foresee the immediate future and say, well, okay, what's the danger here? What are we dealing with? And having the ability then to adapt to that so that we can survive. But of course, when a big breach happens and it destroys the company in terms of reputation, in terms of finances, then you're no longer viable. Now, there is an argument that data breaches are generally not endangering viability as such. That you might have some reputation damage. You might have
there may be some fines. They just pay and move on.
You might find your share price drops, but longer term, you may find that your damage isn't that significant over time. So are those companies resilient and viable because they have mechanisms already within their structure that allows them to ride those sort of like huge data breaches? For example, so we've had Jaguar with Land Rover, we've had Marks and Spencers and Co-op. We've had those breaches recently, and those companies haven't suffered. I mean, Marks and Spencers is still the place where the other middle class goes to do their shopping. So they're not damaged in that way. They might have taken a bit of a blip when it came to their their share price and their immediate problems, but they're able to ride that. Equifax is another one, right? So they, like you go to any presentation on security in the last 5-6 years, or maybe more, 10 years there now, so as it was. If you go to any presentation on it, Equifax is going to come up somewhere along the line. Equifax is still doing really well. It's still out there. It's still trading as a business. It's still seeing probably growing a lot of elements of data, but I'm pretty sure they're still viable and progressing very well. But that blip was significant at the time. Again, if they resilient, but there are other companies, of course, that we know that have been completely destroyed by a breach. If we can understand what makes a company survive and what makes it not survive, that's perhaps where we need to start looking, and that's where perhaps your system thinking approach comes into it. Like, what is the system that, say, Marks and Spencer's is in that allows it to survive, whereas another company hasn't been able to survive a data breach? What's the difference? Is it because it didn't have the funding? Didn't have the backing? Did it just not have a security team? Did it not have a recovery process? What is it that stopped that team from being viable? And I said resilient as well. So I think resilience is very important.
Just developing that nuanced view of risk. What's going to completely ruin you, wipe you out, make you go bankrupt, versus what's going to damage you but still would give you enough time and would leave you with enough resources to recover from that reputationally and survive. So I think that is a fine balance.
Going back to the organism that dries out in a desert, for example, you have got organisms that survive that drought. So they're water-based, but they can survive a drought. Why is it they've done that? That's because they've evolved into being able to do that. So there's something within the system that allows them to survive that. And it may not be evident. It may not, it's very difficult to, that's like biology level to understand why it survives. We could do experiments and test different things. Maybe that's something we need to do as organizations as well, is actually try and work out what is it that makes them viable. And how can we evolve organization structures, like common organizational structures that are resilient to cyber attacks. So, and something else looking at it from a systems thinking perspective is how do we do that?
Like when it comes to VSM, like one of the challenges or one of the perceived challenges is recursion. Many practitioners get confused by it. And what you are trying to do is basically structure the security org based on VSM. And if you've done that at that local level, then how do you actually go about identifying the gaps of the containing system, the organization itself? And then once you identify the gaps, then how do you go about dealing with it?
Yeah. So the recursive system, so going back to like the system one, you could have multiple system ones within the overall system, but that system one contains within it other whole systems, viable systems within it. So when Stafford drew it, he drew it recursively. It's like almost like a Russian dolls. Now, identifying security in that, you could argue that there's not just a single cybersecurity system. There are multiple cybersecurity systems. And you used the word symbiotic earlier, and it should be create systems that work in symbiosis so that the developments, the AppSec is working with the SOC, is working with perhaps even the salespeople that are trying to sell products to the customers, but trying to show them that this, what are the barriers that are stopping, customers from, buying because of insecurities, or even hindering the customer in terms of how we design security into the products that so for example, using passwords or two-factor authentication, things like that. So going back to what I said earlier about how we can then have this cohesive line that joins all these like subsystems together, I think that's the bit that's we're not seeing. So we're not working recursively as such in terms of like having a security system, and within that security system we have like the SOC system and the AppSec system and the UI interface security system. What we currently have is like a developer system, and inside that we have AppSec, and then we have like well, I guess it's production support, could be SOC, and these just don't talk to each other. That SOC is over here and AppSec is over here, and they just never ever talk to each other, and so we end up because communication is just not there. We end up with a system that's just fractured. It's not recursive. It's just a lot of disparate systems all over the place, sitting within this umbrella of a company or organization. So this recursion is very important. I think is to actually understand, like, how do you design your security system or function, I guess, within your organization, and how you can then recursively join all these people. You sort of see CISOs like in that type of role, like trying to be cohesive. But actually, my experience working with clients that I've worked with, when you drill into it, the different security teams are all over the place and they're just not talking to each other. That's not recursive. That's just random chaos. And that's probably where there's a challenge. And even procurement, right? So, going back to SaaS earlier, you say you need a SaaS tool because you need to be compliant. Developers might say, I see this tool here is really good. And then another team says, oh, we use another tool. This tool's really good. And we really love it. And the reason why that is the case is because, they have different technologies that they're using within those different teams. Then it goes to procurement. And procurement says, oh, no, we're going to buy one tool and everybody has used that tool. Yeah. That's not cohesion either. That's the wrong side of cohesion. That's just basically trying to fix everything with a single tool, and it doesn't do that either. So, but if we're able to say, well, actually, AppSec, in this part of the system can work with this type of tooling and develop those sort of recursive structures as well. The thing about VSM is that you have to sit down and model it. And actually work with it and understand where your system boundaries are. Like I said earlier, it's very difficult to understand where your boundaries of the system are. And because there are multiple systems within a system, then you have to start looking at where those boundaries are. And that's how you'd use the VSM to do that, and understand where your gaps are and understand where your challenges are. And you might even start to understand, actually, we've worked out that we got like the system 1's in place and the system 2 communication channels are working okay. But we've got nobody looking outside into the environment to see what's happening in the future. And that's like, where are the attacks coming from? Where are the opportunities coming from for new tooling or new opportunities? AI's called us out, all by surprise. The ChatGPTs and OpenAI called us all out because no one was really foreseeing it. AI's been around for years, many years. I mean, Warren McCulloch, very up with an AI since back in 1950s. So it's not new. We've got even like language models. Language models are not new. They've been around for many years. Google have been using them. Amazon have been using them. Every time you used to shop for something on Amazon, you said, you bought this, you may be interested in that. There was a language model sitting behind that. But then OpenAI made it more accessible, and people said, "Oh, I got this new thing." And actually, we've had our system 4 in place. We might have actually been a bit more. We might have actually recognised it approaching a bit quicker, and dealt with it a bit in that drastic way that some companies have done. Like some companies have gone all in, and even there with Anthropic and Mythos and how is cybersecurity going to deal with these new tools? Again, it's very reactive. It's very there's no one looking outwardly to what the possibilities are and how we can adapt our system internally to deal with those before it actually happens. But I think that's something which the viable system model can help you with as well, those sort of gaps.
On the flip side, I think one of your findings that was remarkable is where practitioners were already operating a VSM-like structure, if you will, with communication forums and alert thresholds and recursive security roles and things like that. And so if you have seen that as an emergent structure that is effective, that has evolved over a period of time. Like, what does that tell us about how do we communicate this or introduce this in a new organization?
Yeah, these are very good questions. Yeah, so I think so. When I was doing my research and I was describing the VSM to the people I was interviewing, when I was talking about the communication channels, for example, and saying, this is how we would communicate to other systems about what we're doing, and communication is very important, they started to draw out things such as, communities of practices and forums and so forth. And so we have that in place. I think that is true. They do have these sort of like pseudo systems in place where they can do this stuff. But what I found is that the, just because obviously I didn't publish everything that they said, I was limited to work out because it's a master's and a thesis after all. But what I was saying is that there's no cohesion between these different forums, these different communication channels. So, and like, so you'd have a small group. This is going back to a question you asked earlier. You have this small group, the local group, that has security forums. They might have a group of security champions that do regular talks with the developers about security and helping those teams and communicating issues back up to the next level of the recursion, and so forth. We're having them at that local level, but what we weren't having is that done globally. So what happens then is that we have this one team that could be doing really well and looking pretty promising in terms of viability, but then you have another team that hasn't got any of that in place. And so it's not just about trying to get a lot of organizations to set this up, it's also within organizations. How do you then communicate it to others? And it is like the buckets are always going to be resources, finances, time. These are all going to be issues that are going to stop you from doing that. Even if these teams can say, no, if you set this up, this will be really good. This will really help you. Quite often, these initiatives within an organization are run by people that are quite passionate about what they're doing. And I think that's another way. It goes back to psychology, what David said. It's, if you have people that are really engaged and really want to do this, then it will happen. So that's the challenge. We are human after all, and we're not cogs in a wheel, and we can't be forced to do anything. So yeah, that's always going to be a challenge. So how do we then communicate what's happening in this group, and how do we communicate in another group and say, actually, if you do this would be a really good thing to do. I think you've got to show them that actually what you're doing right now doesn't work. But do they understand that? Do they understand that they might not be viable? Is that a risk that they're willing to take at the moment? Talking about risk again. It's a challenge. I'd love to explore this further with other clients, to try and understand how we can develop a more viable system, and understand how these communication channels can work, how we can build systems that are more inward and outward looking, and how we can create controls around that. And I'd love to work more with clients to see how we can develop that further, because as Stafford Beer sounds, it's actually practice that makes these theories come to life. We're always going to look to develop for find problems that we're going to have to solve and new ways of doing stuff. So yeah, I think that's my take on that anyway. Is that there's no blueprint and say this is how you do it.
Yeah, I think there's some level of a zero-sum game attitude or mentality behind that, which kind of takes me to the next question. Like, in your research, you found that leadership was messaging explicitly to deprioritize vulnerability work in favor of feature delivery. And so this is not really a technical problem, but more of a governance problem, if you will. But how did you kind of frame this ever persistent zero-sum conflict of, hey, whether it's business or security, or velocity and security, and whether it's productivity and security. There's different ways certain leaders position them. Like, but how do you see it?
I think it goes back to incentives again. What are your incentives for doing it? And I think some developers are incentivized to do good code, write good products, develop secure products for their customers. I think they're incentivized to do that through that intrinsic motivator. Then you also have some people who say, well, it's never going to happen to us. One of the most common things I've seen actually with our clients is, oh, this tool won't be used by our clients, it's going to be used internally. And then when you realize that you're just actually developing something in the supply chain for your customer, it's still a risk. So maybe there is also that element of people just don't realize the risk of the product they're developing. And so it's communicating that to them and making them realize that there is a risk. Obviously, that challenge that we have between like velocity and getting product features out and so forth versus developing secure products is there's always going to be that tension between the two. And I think that's purely because security can be quite invasive. It can be quite disruptive to try and do something in a secure way. Going back to what I said earlier about the safety, like if you've got to go down the ladder before you can go back up another ladder, that's invasive. That's not really helping you use your flow. You need to try and develop systems that help developers with their flow, so they can develop products for their customers in a good way and secure way, but at the cadence that they want to deliver to the customers. Maybe there's also a bit of education with some of the people that are delivering these to the customers as well. So does a feature really need to be delivered that quickly? What is the speed? Why speed all the time? Again, this comes back to John Boyd's OODA loop, right? John Boyd was never about speed. It was always about doing the right thing at the right time and making the right decisions at the right time. It was never about making a decision faster. It was making a decision more effective and more efficiently, which is totally different to doing it faster. So if efficiency means that you've got to be more secure, then that's something we need to start, thinking about as a solution is developing products that are secure. Almost at a risk, and risk appetite changes from one person to another as well. So, even within an organization, you can have one team that's doing stuff really well, really good, secure. You have another team that's not secure because they're developing internally, or their product manager or product owner is not really is not really worried too much about risk and is happy for the product to go out in a less secure way, maybe because they feel like the impact is going to be lower. I don't know. It's a tricky one because if the cousin the question, we saw security.
I think it's just that the whole view that this is a zero-sum game that we're playing, whether it's security or features. I think that's fundamentally wrong in itself.
Yeah, of course. Yeah.
Right. If there's one thing that I've learned from systems thinking is never to get into a versus B situation. There's always a creative C, or there's infinite ways of looking at the problem space. And I think that's what even going back to your Deming references, that's what Deming proved, that you can improve profit by cost cutting. That's what the vast majority of mainstream management does. But you can also improve quality and reduce the cost to your customer and improve delivery. Like you can do all of that, reduce, the lead time. It's just that you have to play a different game and you take a completely different look at the problem space. And if quality is like that, security is no different. And so if you're able to ship features faster, if you're able to improve that pipeline, then of course you can fix vulnerabilities faster. And so I think there is a different way of looking at the whole, and it's going to be very context dependent how you frame it to your customers and what incentive structures they have and so on and so forth. But I think if we can just flip out of that A versus B mentality, I think that itself would open us up to a lot of creative space where we can explore other possibilities.
Well, definitely. Yeah, definitely. I agree with that. And that's why this whole reductionist approach really is the paradigm we're in at the moment. Is either this or that. It's always going to be a choice between two or more items, and actually systemically you can do a bit of everything, and do it well. Deming said that about, if you improve quality, you can reduce cost. I think Taichi Ono really brought up more as well in the Toyota production system. One of the things that I was always fascinated about. So Gene Kim talked about the Andon cord that they use at the Toyota production system. The idea of an Andon cord is that if if an engineer sees that there's a problem, he can pull the Andon cord. It's a problem nowadays, but you can pull the Andon cord. The production line will stop for a moment, and you can then go and troubleshoot that particular problem. If the problem isn't fixed immediately, then the wider production line is stopped, and so they will then I can't remember, swarm it, I think is what they use. They'll swarm it to fix the problem, and then they'll let it go on. And I think Gene Kim used to ask the question, how many times do you think in a day the Andon cord is pulled? And it's like thousands of times a day the Andon cord is pulled. Now I think about cybersecurity and I think about software development. How many times do we stop the build? How many times do we swarm a defective build to try and fix that particular problem? And especially when it comes to security problems, we don't. This is where it goes back to the problem of SAST again, isn't it? So in SAST, we run it further down the pipeline where we discover all these vulnerabilities. And yet, if we were to build more regularly and fix the problems when we see them, we wouldn't have that challenge of having vulnerabilities later on down the pipeline, and would have better quality, and it would be cheaper because we're not having to deal with like bringing in people to triage these vulnerabilities in the future and try and fix them, or even facing compliance fines, regulatory fines, and so forth. So yeah, there is definitely value in ensuring that you build quality in from the start, and that includes building security from the start. And that means, for example, having the Andon cord on your CI/CD pipeline to make sure that you are stopping the builds as soon as you see a problem. And if that build cannot be fixed by that developer immediately, then swarm it, get people to work on it and get it fixed, and then move on to the next feature or product that you're developing. I think that's something we can learn from the TPS, and I think academic said that multiple times, that the quality reduces cost. And we're not seeing that in cybersecurity. We see cybersecurity as a cost issue, which really shouldn't be the case. If we did things right in the first instance, we'd be okay. And if it goes back to what I said about having the system looking after itself, this is cybernetics at its finest. There's a problem that needs to be fixed, and it gets fixed immediately. That's how cybernetics is. Cybernetics is about adapting immediately to the environment around you, making changes. But we don't do that, and so we end up millions of vulnerabilities we can't fix, and cybersecurity being given a bad name because we created all this work, and attackers love it. And if there's one group of people that work in a systemic way, that are working in a symbiotic way as well, they are attackers. Attackers really are well organized. They adapt to the environment around them. There's no command and control. It's just done in a systemic way, a systems thinking way, and that's possibly the reason why they're doing so well. All of the attackers,
they understand human psychology way better than some of the defenders.
Exactly. Yeah, they really do. I mean, maybe we should all go and work in a state actor, like a hackers team, and say, well, this is how they do it. Okay, fair enough. This is how we should be defending users. That's another thing, right? State actors get huge amounts of funding to do this. Say hackers, but companies are not willing to spend on security within their own organization. And I think that's, if you realize what you're up against, then your budget for security. If you're going to work on improving quality and reducing costs, then certainly focus on how you're going to secure your products as a and invest in that. Not necessarily invest in tools to fix every problem, but invest in the way that you're going to try and improve the quality of your products and improve the security of your products.
Yeah. I think, of course, not everyone has to worry about state actors, but there are large corporations here in Silicon Valley that definitely have to worry about state actors.
Yeah, but the supply chain is certainly a weakness, and we are seeing a lot of state acting against supply chain. We're seeing vulnerabilities that are directly attacking smaller companies because their clients are huge companies. SolarWinds is a great example of that.
That's a good point. And so my original point was, it really comes down to who has the capabilities to defend against somebody who's as motivated and as funded as a state actor. They can be very, very, very persistent over long periods of time and finally get you over. So it really becomes a very dynamic, complex game, and sometimes you will have collateral damage, other smaller companies getting blasted, and so on and so forth.
Yeah, definitely collateral damage is another risk, isn't it? I mean, that happened to the UK NHS. So the WannaCry worm, which wasn't targeting the NHS, it was targeting an operating system. Just so happened the NHS was using the operating system hadn't been patched, because if they'd patched it, it would have broken critical systems that the NHS use. And so the WannaCry virus spread or worm, I should say, spread fairly quickly in the NHS. Collateral damage. And the other one, of course, is Maersk. Maersk was collateral damage. It was an attack against I think it was a Ukrainian finance company. It just so happens that Maersk was collateral damage today. Maersk wasn't a target. It was just
interesting.
Yeah. So there was an interesting article in Wired magazine a few years ago about that.
I see. This conversation takes me back again to using viability as the lens of, okay, is this going to completely take me out of the game? How do you use viability for risk management? And how do you rate certain, can you use that? Because, one thing you don't want to be is a security purist where, you're not worried, you want to fix everything. And on the other end is, I'm not going to fix anything. So how do you strike the right balance so that viability doesn't get impacted in the process?
Yeah. So that's making the assumption that you've got hundreds and thousands of vulnerabilities you need to fix. I think that's the. So if you're looking at it from another perspective, why do we have all those hundreds of thousands of vulnerabilities? That system needs to change to stop that from happening, because we're still only patching the problem. We're still putting a sticky plaster over the problem. We're not really dealing with the actual fundamental systemic problem. We're taking a reductionist view of it and say we've got to fix these vulnerabilities. That's not the right way of doing it. We do need to fix vulnerabilities at some point, but in order for a company to be viable, they need to think about how do they prevent those vulnerabilities in the first place. How do they develop software in a secure way, and how they're enabling the developers to do that without developers having to go on security courses and so forth. There are better ways of doing it, and we need to think of better ways of doing it. I'm always going to harp back to the whole idea of safety. We're going to take shortcuts if the system doesn't allow us to do things with flow, with easily. If we're going to, if it's going to be harder to do security, then we're not going to do it. So how do we improve that element of our software engineering? Not how do we fix vulnerabilities, because that is already too late in the system. It's too late in the process.
Yeah. I think that's that, flip in the perspective where you're saying, hey, the vulnerability is not the problem to be solved. A vulnerability is merely a symptom of the underlying conditions that led to it in the first place. So go take care of that. rather
Yeah.
than thinking about. So all of these tools, the SAST, IAST, DAST, all of these tools that most vendors in the industry provide you are symptom detectors.
Yes.
And
Very
you are
much so. Yeah.
drowning in thousands and hundreds of thousands, in some cases millions of symptoms,
Yeah.
which you have no way of pattern matching and saying, okay, all of these vulnerabilities are cross-site scripting, reflected cross-site scripting vulnerabilities that come from not using the latest version of blah framework or whatever is the framework that you're using. And all of these infrastructure vulnerabilities are coming from this OS, single OS image that's everywhere in production. And so you can kind of figure out ways to go back and solve them. And some of them could be social in nature, like this person's not talking to that person or whatever,
So,
or,
yeah.
or budget constraints, or you identify and start removing. So it's really it then becomes a very custom look at people in the eye and work with them, have
Yeah.
conversations and work with them, kind of an exercise, rather than, following best practices or running a tool and just trying to drown that.
Yeah. Best practices. I hate that word. That's suggesting that we're doing the best way. We don't have to look at any other way. Yeah.
Yeah.
No, I totally agree. It's yeah, we are trying to deal too much with the symptoms. I use the analogy and said if you come up with like you suddenly find you've got spots all over your body, and you start to think about, okay, how I'm going to treat this. You can either treat each spot individually, and you might treat certain spots with more priority than other spots because they might go on your face. You don't want
So the
people to
face
see
or
them.
something.
Yeah.
Yeah.
But actually, what you haven't done is actually worked out why those spots appeared in the first place. And it could be that you might have a virus, or you might have an allergy, or some other condition that's causing these spots to appear. And you're not dealing with that. You're only dealing with the actual getting rid of the spots. Like say you might put the sear over them or whatever you're doing like that. You're not dealing with the actual problem that caused those spots to occur in the first place. And I think think about vulnerabilities. It's exactly the same thing. If we're dealing with vulnerabilities one by one, we're just basically popping zits. Like, kind of put it that way.
Akoff
But,
put it, the best place to solve a problem is seldom where you find it.
yeah, he's absolutely right. Yeah, I love what Akoff said that. I mean, I love these. We won't talk about it now, but there's a lovely story about people waiting for lifts, and Akoff came up with a solution for that. Yeah. I was like, oh, that's a great one.
Connects well to our understanding of human psychology.
Yeah.
As well. I wanted to briefly we mentioned about person A not talking to person B and why that information flow is broken. That's what you really see in practice when you're applying VSM to an organization. And so are there any interesting anecdotes that you want to share from your experience? Of course, you don't have to mention client names or anything like that.
Oh, well, people not communicating. Yeah, the main one I see really is when developers from one team do, like, say, a scan and they identify vulnerabilities, and another team does the same sort of thing. What I see time and time again is that you've got almost exactly the same set of vulnerabilities that appear in these two different systems, and yet there's no communication between the two about how we're going to fix these. Like they go off and fix it on their own. My book tried to try to deal with that in some respect. It's like saying, like, let's look at the whole system and saying, okay, let's just tackle one type of vulnerability at a time across the whole system and get everybody working on the same trouble, the same issue. And so that's an anecdote I can quite often think about, is that teams just don't talk to each other about the same problems that they're facing, especially large organizations. Yeah, I think it's a difficult one. And there's so many things that I can think of that just come to my head, but I can't think of one particular instance that I could tell right now. Really, it's
Sure. It's
Yeah.
it's
It's just, there's too many.
it's a very human
Yeah.
problem that's difficult to articulate in some cases.
Yeah.
Um, you know, yeah.
Yeah. I think so. I think, you know, what I think also is that we quite often expect the developer to know what to do,
Mm,
and know how to do security. And there's been a lot of talk about that recently. I've written about it in my book, for God's sake. Plus, security education was one of the layers I put in there. We need to educate these people to do security better. But, my orientation has changed. We can't know how to do security all the time. It's not like that.
yeah.
You got to take for granted that some of the stuff that we're doing is secure. And so think about houses, like our houses. We don't really understand how the houses are secure. We just know that if we lock the door and lock the windows, our houses are secure. But there are other things that are also relevant to why we're secure. The location we're in, it plays a factor. Or other overlooking neighbours. That means that it would be very easy to see someone who's intruding into your property, for example, from elsewhere. There's lots of other reasons why you're secure. It's not just necessarily the physical locks on the door.
Mm,
And I think, we take that from a security organization perspective. What is it that's keeping us secure from that? It's not just we've got secure software. Do we have a mindset of security? Do we have people that understand what, that if we're going back to the, people overlooking us and seeing intruders, what are we doing to identify where there are potential intruders within the organization? Like in the APTs, for example, do we do that? We're only focusing on trying to find vulnerabilities. We're not really focusing on other things, like that, such as APTs, such as that door's been left open or that window's been left open. Is that particular piece of software running and it doesn't need to be running? These sort of things
mm,
that we need to think of as well. So I also think that's something we need to do better in security is going back to this whole systems thinking thing is it's not even about layers of security. It's just about a mindset of security, how we secure our organization from different angles and different ways of thinking about it. And thinking about it as a system rather than thinking in, let's just focus on vulnerabilities. That's not going to work. Or let's just focus on incident reporting, incident management. That's not going to work either. You've got to
mm.
understand the whole, why are we secure? Why are we insecure? And so that's the closest I can get to anything. I think that's what is like. And the reason why I say that is because I know someone who got burgled recently, and like I was thinking, why was that house burgled? Well, it was like at the end of the terrace. It was behind a great big hedge. There was nobody ever looking at it. The doors and windows were locked, but somebody was able to break in. Key was left in the window and stuff like that. So you start thinking about that. You start thinking, okay, well, that was why that was burgled. Well, because anything in particular, it was a lot of different things that made it insecure, and that's exactly the same as organisation. An organisation has multiple reasons why it's insecure.
Things in life are multifactorial. It's never one root cause as much as we would love to go and find it.
Yes. Why,
Um,
why?
yeah. Um, Given all of these ideas, um, can you leave the listeners with a couple of heuristics, looking at specifically cybersecurity leaders like CISOs, Chief Information Security Officers? What heuristics will help them when it comes to organizational design or anything that they have to do from a cybersecurity perspective, improving the effectiveness?
Yeah, I think as that's what we've been saying all along really is don't look at the symptoms. Don't look at, just fixing vulnerabilities. Don't just
Mm,
focus on that one item. Look into why are you producing those vulnerabilities and why is your system behaving in the way it does. That to me is very important. And that's something I would like all leaders to think about. Is not just, okay, I'm the CISO, I've got this compliance thing I need to reduce all my vulnerabilities. That's not, you don't then throw those resources at trying to fix those vulnerabilities and start penalizing and punishing people because I'm not doing it. That's not the way forward. The way forward is to, how do you change the system to prevent those vulnerabilities from being written in the first place? And then how do you address those vulnerabilities in a way that isn't just picking off the high priority ones, but actually really understanding what the actual security risk is with each of those.
Awesome. Well said, Glenn. Uh, I want to wrap up, but this is one question that I ask all of my guests. The CyberSyn community, as you know, has many cybersecurity practitioners and executives from here in the Silicon Valley and across the globe, and they're all exploring multidisciplinary insights from systems thinking, complexity, and we've done a couple of podcasts actually on VSM. I've written about it on the newsletter as well. Any advice you have for them? Because they are on that bleeding edge, on that frontier of exploring these ideas. So anything that you want to say to that specific audience?
Yeah, I think what I'd really like to convey is don't leave security behind when you're innovating, when you're moving ahead, when you're forging ahead. If you're developing new products, and especially if those products that can be used to develop other products, for example, like say you're developing new tools, think about how your developers, the developers of your customers, how would they be secure? How would they keep their products secure based on what you're doing? And think about it that way, rather than just thinking, okay, we've got to get this out the door and just leave it to other people to try and fix it. Any issues that they might see. So they're not vulnerabilities that you're delivering as such, but how can you make it easier for your customers to keep secure and remain secure? And I think that's something I'd like to convey. I think also, how can we work together and develop more secure products? Because, as I said earlier, attackers have this symbiosis. They're system thinkers. They are adaptive. They are working in complex environments and they're doing it really well. How can we, as a, I don't know what's the opposite of attackers, but how do we, the defenders, how can we ensure that we're working as a community and as a group to combat these people, because they are working in this symbiotic way? How do we create this symbiosis? So rather than being too competitive against each other and because we're competitive, we're not really winning the war against the real people that we're competing against, which are the attackers.
Awesome. Glenn, any other questions that I should have asked but didn't, or any parting remarks for our listeners?
No, we've covered a lot today, and to be honest, you've asked some really great questions, and I'm probably rambled on far too much, but I just want to say thank you for giving me this opportunity to talk about VSM. I love VSM. I love FUDA. I love the whole idea of cybernetics as well. I know cybernetics has moved on a lot since the 1940s when it was first written. We've had different waves of it. Ultimately, it all of this comes back down to how do we exist and remain viable as a system within the environment? And I think that's something which I think is such an important takeaway really for me is that, what can we learn from viable organisms to create viable organizations?
Yeah. Awesome. Glenn, thank you so much for being so generous with your time and sharing your insights with the listeners. Thank you so much.
Oh, you're welcome. It's been a pleasure.